Okay guys, these are the notes that you're going to be taking today while I'm not in school. The papers are on my desk called Limiting and Excess Reactant Notes. They look like this, so make sure you get a copy of this and then you can get started. Before we get into solving these mathematical problems, you do need to know a few definitions first. So the first one you need to know is limiting reactant. This is the reactant that determines the amount of product that can be formed in a chemical reaction. In other words, it limits the amount of product that you are able to form. So that is limiting reactant. On the other side, on the other hand, you have something called an excess reactant. Excess meaning extra. This is the reactant that is not completely used up in a chemical reaction. So this is what you have left over at the end of a reaction, and we refer to that as excess. So you're going to be asked a few questions. How do you determine the limiting versus the excess reactants in chemical equations and chemical reactions? So I'm going to show you two methods on how you do this. Our example problem is, let's see, 80 grams of copper react with 25 grams of sulfur to produce copper 1 sulfide. What is the limiting reagent, meaning reactant, same thing, and what is the excess reagent? Method 1, you're going to be comparing reactant to reactant. Now, I personally don't love this method. It's a little less work-ish, but I'm going to show it to you anyways so you can make an informed decision. So our first step here is to convert the given amounts of each reactant to moles. So as you can see in this problem, and I'm running through my colors, we are given 80 grams of copper, and we're also given 25 grams of sulfur. So that's the big difference here. When you have limiting reactant problems, you have two givens, okay? So step 1, convert your given amounts into moles. So 80 grams of copper, converting that into moles, you have 1.259 moles of copper given. Same process for the sulfur. I forgot some units, but that's okay. And we know that we have 0.780 moles of sulfur given. Once you do that, if you are not given a balanced chemical equation, you're going to write that. Okay, sometimes you'll be given it, sometimes you won't. Now, what you need to do, multiply, this is step 3, multiply the given amount of moles of each reactant by the mole ratio, it's not going away, from the balanced equation to determine the number of moles needed, this is key, needed for each reactant. So you take your answer from here, you take your answer from here, and we're using it down here at step 3, okay? So you're taking your 1.259 moles of copper, multiplying it by our mole ratio, and we're figuring out, hey, we need this many moles of sulfur to use up all of this copper, okay? Same thing with the sulfur. We're taking our answer from up here, multiplying it by the mole ratio to figure out, hey, we need 1.560 moles of copper to use up all that sulfur. So that's the math. This is the math that you do, okay? Then you have to think analytically. You have to think about the numbers. I like to think, and I have this explanation written out here, but compare the number of moles needed to the number of moles given, okay? So I like to think, and I'm not prepared, I should have had a pen. I like to think this right here, we have, okay? We have this. It's given to us, we have it. This down here is what we need. So the question is, do we have enough? If we have enough, then that is not limiting. If we do not have enough, that limits how much we can make. So we need, and it gets a little confusing here, this is of sulfur, okay? So we need 0.6295 moles of sulfur. Whereas over here, for our copper, over here, we need, and if you have to write this up on your paper, go for it. Sometimes it's easier to write things out. So we need 1.560 moles of copper. We only have 1.259. So the question I pose to you, do we have enough? You should be thinking no. So no, we don't have enough. We need 1.5 whatever. We only have 1.2 whatever. Over here, we need 0.6295 and we have 0.78. So we have plenty of this left to go around, okay? That's basically what this explanation says down here. I won't read that to you because that's annoying. So you can read that yourself, okay? Let me flip the page. Now, we're getting into method 2. So this is where the regular old stoich comes into play, okay? So it says, step 1, step 2, step 3, so on and so forth. We are comparing how much product can be made from each reactant. So, step 1, write the balanced chemical equation. Step 2, you're setting up 2 stoichiometry conversions using the given and find for each reactant. So again, the problem states we have 80 grams of copper, 25 grams of sulfur. How much copper 1 sulfide can we make? So see, we have one setup here and another setup there. So we're setting up 2. They both have given and finds. Nothing's changing. We just have 2 to do now. Then you're going from grams to grams. So this is a mass to mass conversion. Mass to mass. So the setup is exactly mass to mass. So here, for our copper, we go through the setup, go through the mole ratio, use the molar mass, and we figure out, hey, 100.18 grams of copper 1 sulfide are produced, versus down here with our sulfide, 25 grams of that going through the same process produces 124.07 grams of our product. Someone's at my door. Brief intermission. Okay, so look at that. Hold on. Sorry, I'm making a video. This from Miss Savage. Yes. Thank you. All right, a brief intermission. There's no peace. That's okay. So when we get to this step 3, are you with me? When we get to step 3, we don't have to think about what we have, what we need. We just need to look at the facts. And these right here are the facts. Which one makes less product? And you should be thinking, oh my God, that is less product. Our copper is our limiting reactant because less Cu2S is made. Therefore, this guy at the beginning limits how much we can make. And that's it. So, this video is getting long. I'm gonna stop it. I'll walk you through this example in the next video if you need it. I would highly encourage you to watch the video, but live your life. Okay, good luck.